Hello everyone. Today we have come back again with a new topic, that is types of load. So moving on to the next slide. So following are the types of load that a machine member is subjected to. Okay, so first one is the static load. Okay, so now what is a static load? So it is a load which remains constant at its magnitude, direction and location. According to this definition, a hanging weight on a bar is an example of this type of load. The load may be a point load or UDL or UVL, that is uniformly distributed load or uniformly varying motion, as long as it doesn't changes its value with time. It is called static load. Okay, so design against such load is easy as compared to other types of load. So static load is a load that doesn't change its value with time. So okay, so it remains constant at its magnitude, direction and location. So next, moving on to next classification, that is dynamic loads. Okay, so a dynamic load is one which shows variation in magnitude or direction or point of application. The best example is the wind force, which is never a constant force or load. Okay, so you have obviously observed the wind force, which is never a constant force or load. Okay, since dynamic loads are quite uncertain regarding their variations, hence sufficient reserve strength must be kept while dealing with them. Okay, so dynamic loads are very uncertain and we have to be aware and we have to reserve strength while dealing with the dynamic loads. Next is the cyclic load. Okay, so first let us see what is cyclic loads. Okay, so cyclic loads are the dynamic loads which exhibit a specific pattern at their variations. Example of cyclic load is the inertia load on the connecting rod of engine. Okay, so such loads cause the fatigue failure in the component they act on. So while designing for cyclic loads, sufficient endurance strength must be ensured. Okay, so we must ensure sufficient endurance strength for such loads that causes fatigue failure. Okay, so such components are designed to withstand endurance limit stress rather than mere ultimate stress. Okay, so design should be designed such that it will sustain infinite cycles of such load. Okay, moving on to the next is the impact loads. Okay, so here instantaneous large load produces the impact load. It may be due to collision, falling or sudden jerk. Okay, so these forces are very large and instantaneous. So while considering in design, they must be dealt with sufficient reserve strength by taking higher factor of safety. Okay, so with this we have come to the end of this topic, that is types of load. Thank you everyone.